In this video, we will be going over SSL Deep Inspection. And before we get into that though, let's quickly go over how HTTPS works when we're communicating between a client and a server. So for example, let's say we're trying to access an HTTPS website named testing123.com. So what's great about this communication is that it's going to be encrypted so that any entity in between the client and the server that gains access to this communication, they fortunately will not be able to see inside that communication without any type of encryption or authentication keys. So it would be very, very unlikely that they'd be able to gain that access. Now let's go over quickly how that actually works. So what's involved here is a certificate authority. So a certificate authority might be something that we've heard of before, such as GoDaddy as a certificate authority, Google certificate authority, maybe VeriSign, but they're third-party entities. And how the process would work is that the company, testing123.com, for example, they would be reaching out to a certificate authority asking for a server certificate. So the certificate authority, once they research this company and validate that they are who they say they are, and they're, I assume, a legitimate business, however their process works, the end result is that if they confirm that they will be providing a server certificate to the company requesting this certificate, what they will do is they will generate a certificate which is signed by the root certificate authority certificate. So that's the one that I'm kind of hovering over here. And then that certificate signs this server certificate, which then is placed on the actual end server that's hosting this testing123.com website. Now, going back to the certificate authority, if we look at the client machine, and every single client machine will have this, whether we're talking about a Linux, a Windows, or a Mac computer, they're going to have a database or essentially a certificate store where essentially the public key, it's called a public key of the CA certificate, will be installed, or it will already be pre-installed on that client, right? So the public key will be installed on the client, and then the private and the public key pair is what the actual certificate authority will own. And the reason why the certificate authority owns the private and the public key is that that gives them the ability to actually sign server certificates that they give to legitimate companies, right? But then, we definitely cannot have what's called the private key on the client, because then they would be able to sign certificates and it would kind of defeat the whole purpose here. So and you can maybe research and look into the complexities or the in-depth explanations about the private versus the public keys, but essentially just think of it that the client does have the CA certificate, which actually signed the server certificate. It's already pre-installed on that machine without you even knowing about it, right? Whenever there's a new root certificate authority that gets created, your browser in the background, it's actually automatically downloading that. So this is why this process is usually fairly transparent to end users. So the idea here is that since the client already has the public key of the certificate authority, since that certificate authority signed the server certificate, there is an indirect trust between the client and the server. And that's ultimately what, one, it gives us that encrypted communication, but two, it also gives the client the assurance that they can trust that the server is who the server claims to be. And that's why, as the end result, when we're actually accessing the website testing123.com, as long as this whole process is working as expected, then we will see that lock sign. Typically, you're going to see that lock sign if we're using something like Google Chrome, maybe Firefox or Microsoft Edge. All right, so now let's say on our client site, there's a firewall that's installed, and that firewall has deep inspection enabled on it. So first things first, again, we're still trying to access testing123.com, but now since deep inspection is enabled on the firewall, when that communication is attempted, the firewall is going to be saying, wait a second, actually, I am testing123.com. And the firewall has to do this if it wants to have any chance at being able to view the contents of the communication between the client and the server. So what that means is that the firewall has to say, okay, I'm actually going to present my server certificate. The firewall is going to present its server certificate instead of the server presenting its server certificate directly to the client. So that's exactly how the firewall will be able to obtain a man-in-the-middle communication, or essentially visibility to that traffic. Now, since HTTPS is designed as a secure protocol, this is the benefit from the client's perspective. The client is going to say, wait a second, I don't know about any type of certificate authority or CA certificate that's installed on my machine that has signed this server certificate, which is being presented by, in this case, a firewall, right? So the only way to get around that, to prevent this connection is untrusted message, would be to have the CA certificate that signed this server certificate to be installed on this client workstation. And this would usually be installed in a scalable fashion using something like GPO. GPO being in a Windows environment. So once that CA certificate is installed on that client, then now we have it. We can access testing123.com from the client machine, and then to the end user, it's as if nothing has changed. But the benefit here, if we're talking about the perspective of a firewall, the benefit here now is that the firewall has the visibility to the communication between the client and the server. Now, this could be very dangerous if this were to be, for example, a malicious device in between. But in this case, when we have a firewall and then we have that CA certificate, that trust relationship between the client and the firewall here, then the communication works and the firewall has that visibility. Now, a couple reasons why we would actually want our firewall to have that visibility. Well, the main one is if a firewall has visibility into this type of communication, now it has the ability to protect that client from anything that might be on the server, for example, or vice versa. So what I mean by this is, let's say there's a virus that's on this server machine. So now when the client goes to testing123.com, they click a link which makes them download a file. Well, now because our firewall has the visibility to the payload of the HTTPS communication, now it actually has the ability to be able to prevent against that virus, whereas it would not have the ability to protect that client if it could not see into that encrypted communication. And there's also various other reasons why we might want to have that visibility, but hopefully that gives us a bit of an idea as to, how the basics of the HTTPS communication works, what the certificate authority is, the server certificate, and how there's a bit of a process when we're trying to do a man in the middle or trying to enable something like deep inspection on a firewall, why we have to get that client certificate or that CA certificate installed on the client. So for the most part, that's it for this session. Thanks for joining, and we'll see you in the next video.